Well, I will say there's something very unique about this next presentation beyond the fact that they're looking at fence-line contrast, and that's that two of the main authors actually claim to be retired, but it seems like they're continuing to do more and more work. So Dr. T.Booth is retired from the ARS. He is doing some more beekeeping and honey making work, but he's still continuing, along with John Likens and Sam Cox, who you guys heard from earlier, to do rangeland related research. And I'm going to let Terry take it from there. So I tell you, I'm just showing you right there.
All right. That looks good. Okay, and the laser point. Right there. Okay. So I knew I was in trouble today when I heard Rachel say she was old. I want to acknowledge my co-author, Sam Cox, that you heard from earlier today, and John Likens, past president of the section. And a fundamental part of this study, if John hadn't had the foresight 30 years ago to put in 5 of the 6 fences that I'll be talking about, we would not have a study. What I want to do today is begin with a brief overview, kind of set the context or background of why this study was important. Then I'm going to review 3 papers that deal directly with the subject that we were asking questions about. Then I'll go into our hypothesis statement, description of methods, present the results and conclusions, and then I want to go into a discussion relative to that I hope, one, clarifies the importance of what we're talking about, and 2, illustrates, what more than illustrates, kind of provides some backup information. So now let's see if I listened. Nope. Where am I supposed to aim this at? Back here. Back there. Which one was it?
Make sure we didn't turn it off.
Okay. So try again. There we go. Whoop. Well, can't get it to go 1. Let's see. There we go. Okay. So this is a NASA graph that shows the Earth is warming. Now, warming may be due to the Milankovitch cycles in the Earth's orbit. You may believe that. It may be due to man's use of fossil fuels, maybe due to a combination, but I think it's beyond argument that the Earth is getting warmer. And one of the results of that has been a tremendous loss of water, fresh water, stored as ice and snow in the mountains. One consequence of that loss of ice and snow was the very fortunate discovery of this corpse, half frozen in ice, in the Alps at the border of Austria and Italy. This corpse was in the ice for 5,300 years. And you think about how long it's been since the mountains were that free of that much frozen water. The lower picture shows after the ice, pardon me, after the ice had totally melted, the glacier that once flowed over that site, gone. Okay, now the Alps are not the only mountains where we have lost water that can be stored as ice and snow. Researchers at the Reynolds Creek Experimental Watershed, the Wahi Mountains outside of Boise, Idaho, looked at 45 years of water year data. They analyzed for temperature, precipitation, and stream flow, and their findings. We've had temperature increases at all elevations. Larger increases of daily minimum, in other words, usually the nighttime temperature, than of our daily maximum. We're getting more rain. Melt out occurs earlier, and of course that means our stream flow is shifting so that the water's coming off the mountain rather than gradually through the summer. It's coming off faster, even in the winter before the growing season, or early in the spring. So they conclude we have changes of snow deposition, we have changes of melt pattern, this affects stream flow. Therefore, these trends will likely have a significant, and I would change that and say these trends better have a significant effect on land and water management. Land and water management, that's us. We are the land and water managers. So the question we need to ask is what should we be doing to mitigate these changes, to mitigate the loss of storage of water in the mountains as ice and snow. When we talk about holding water on the land, we're usually talking about grazing management. And that kind of boils down to three factors. We want to maintain a vegetative cover to protect against soil erosion. We want to maintain soil organic matter. Now, you'll remember that the soil organic matter is the sponge factor in the soil. It doesn't matter what kind of mineral base you have in your soil, as you increase the amount of carbon or organic matter, you increase or even multiply the water holding capacity of that soil. So we need to maintain the organic matter by annual replacement. We lose organic matter all the time through oxidation or erosion, wind erosion, water erosion. That needs to be annually replaced in the soil. And the third factor is to maintain topographic forms on the landscape that slow runoff as opposed to speed it. You know, rills, gullies, that just shoots the water through the landscape. We need topographic forms that avoid channels and spread the water out. I better check my notes. But I guess I'm in good shape. I mentioned that I wanted to review 3 papers, and so we're into that. This is 3 publications. I don't know if, anyway. Manguson et al., 1998. This is out of Iceland, and I do want to read the quote, so I better not go from memory. All right, this state hummocks are usually a very distinct character of Icelandic rangelands where grazing has been intense. End quote. Now the problem with this statement in this publication is that this is an observation of correlation. It does not establish cause and effect. The next publication is Corning, 2002. He observed that Wyoming wetlands south of the Sweetwater River, upper Sweetwater River, are, quote, becoming hummocked areas rather than true riparian wetlands, end quote. And he attributed the hummocks to cattle compressing the organic matter, causing trails that would form channels that dewatered, took away from the wetland. So he said this is due to cows walking through the wetland and draining it. The problem with that publication is that although he shows photos, several photos like this, he provides no data, absolutely no data that show a cause and effect. The third is Carey and Johnson. They agree with Corning that these hummocks are caused by cows walking through the wetland, compacting the organic matter, and then you get erosion after that, and that's what forms the hummocks. And they show several examples. In this example, they're calling attention to the steep sides of the hummock and the amount of bare ground. And another example that they show. Johnson and Carey also differentiated among the types of hummocks. This they call a natural hummock, you might say good, and they explain that this sort of hummock forms around perennial vegetation as the moss grows, and then you gradually get more and more organic matter building up around the plants. And so this is a hummock that grows from the surface up, whereas the other one that they described what could be thought of as surface down due to compaction and erosion. The problem with this publication is the same as the others. There are no data. You take on faith their statement that this is caused by cows. So, now to our study. We postulated that if grazing was causing the bad hummocks, we should be able to detect this with an erosion bridge. I'll show you a photo of an erosion bridge in a minute. But we could get measurements that would detect a difference if there was really a difference there. And then second, if the reviewed papers, the papers I just talked about, if they are correct, then wetlands that have less grazing should have less hummocks. And that turns into a null hypothesis statement of no difference in microtopography by grazing treatment. So that is what we tested. And again, as I mentioned earlier, we conducted our test with 6 fence lines in 4 wetland meadow complexes, and that was done in Fremont County, Upper Sweetwater River. So here's the Continental Divide. Here's the Sweetwater River. 3 of our study sites are south, 1 north. All right. So 3 study sites are the 30-year-old BLM exposures that were built under John's direction. Now, of course, an exposure means we exclude livestock. But violations of that exclusion are known. There were some fences cut and some wires tied up and a few things like that. But the long-term objective was met. There was a significant reduction of grazing inside versus outside. Then we have one site on TV Creek that is a private pasture that has been grazed 15 to 20 days annually for more than 50 years. And around all 4 sites, we have public land grazed full, season long, 180 days, for the 4 decades since there was a change from sheep grazing to cattle grazing. Okay, here's our erosion bridge. And those of you that may have seen our publication on the laser point frame, It looks the same, right? We took our laser point frame, which had two key elements we needed, adjustable legs and a bubble level, and we attached to that a piece of aluminum channel, 1 meter long, drilled for the 10 pins that you see behind the whiteboard. And that was our erosion bridge, so we could go to each of our sample sites, level it, put our pins in, take a photo. Back in the lab, we used image measurement software to measure the height of the pins above the horizontal bar. Then we took the standard deviation of those measurements, and that became our soil roughness index, SRIs. So I'll be referring to SRIs, which is simply the standard deviation of the height of these pins at a sample site. You might note off to the side here, we have quite a bit of hummocky, part of the landscape there. Okay, so now on to our sample plan. We established our transects either 20 meters outside or 20 meters inside of the fence lines. And they, of course, they were perpendicular to the direction of flow. Now we had a choice. These wetlands have different widths. We could use a standard length transect and maybe not get the full cross-section of the area. Or we could go to an unbalanced design, get the full cross-sectional area, or else fence to fence, and then have to deal with the unbalanced design, and we chose the latter. So we analyzed our data as an unbalanced two-factor ANOVA. So we had 6 fence lines and then 2 grazing treatments and variable number of samples. Actually, our samples in the transects ranged from 9 to 16, and 11 was the most common. Let's see. Okay, I think that covers that. Here are the results. At PV Spring, which is the pasture that had the 50 years of conservative grazing, our SRI inside was 21, outside 108. Atlantic East, which is the east side of that exposure, they're the same, 67 and 67. And then going on down, there were differences. So the overall mean inside was 42. Outside it was almost twice, at 82, which is highly significant. So our differences in grazing is highly significant. We are 99.99% sure that this result is not due to chance. Sites is also significant, but that's not really important because we know that we have differences among sites. So, okay. It is this number that's important. All right, our conclusions. Can we depict micro-topographic differences with an erosion bridge? Yes, we can do that. To our null hypothesis, we have to reject that hypothesis. We have to accept the alternative. And therefore, the claims of Manguson, Corning, and Johnson and Carey are supported. Okay, now let's just talk about wetlands a little bit and some important factors. This is the wetland inside the pasture on PB Creek. Note the cover going into the fall, and if a flood comes down here, a flash flood or spring runoff, it's just going to slide right over the top of this vegetation. That wetland is well protected. There's also a lot of organic matter replacement here. And because there is a lot of organic, we went, can't remember what year, 2010 I think, we measured the amount of organic matter in the soil beneath this vegetation map. 50%. 50% organic matter in the soil. Okay. There. This is an aerial photo, about 1 to 10 millimeters per pixel. And I'm showing this because I want you to see that mat of vegetation. The big sponge in my mind. That is a big sponge. Now we go up a little higher, about 1 to 20 millimeters per pixel. And can you see how this mat of vegetation blocking the waterway is forcing the water up the sides, uphill? You can see the capillary, the water is moved by capillary action through up in here. Now moving on down, we cross the fence, and one of the first things you can see are these hummocks have dried out. Remember, Corning said that the hummocks dewatered the wetland. This is what you're seeing even across the fence. This area has been dewatered, and then it dries out. The wet ground kind of goes like that. This is 2008 photography. Let's go back and look at a series. 74. See the attenuation of the wetland right below the fence? This is color IR, so you're looking at the reflectance of vegetative material. 94, black and white. Again, the attenuation right below the fence line. 2001, you can't see very much, but again, we're color IR. I believe 2001 was another drought year, so we are not getting much plant reflectance except above the fence line. Down below, there's just hardly any pink or red down there at all. And you can better interpret that photo by going to this one, 2012, which we know is a drought. And here again is the fence line. This is still green. It's gradually feeding water out into the stream, which is just a very small stream. And then this area, no plant, no green matter. So you have to think that Corning had a point when he said the hummocks de-water the wetland. This is a ground view of a seriously hummocked area. Think about the change in surface area of this situation compared to the first photo that I showed. With all of those hummocks, you have a tremendous increase. I would say at least twice, probably 3 or 4 times. And that means that much more surface area from which water evaporates. And that much more surface area that causes oxidation of the organic matter. Is this an effective water storage feature? Or is it more similar to this? Water just rushes through that, rushes on downstream, and in 2011, the Missouri flooded, threatened this nuclear power plant, and you can bet that water from the Sweetwater was there with that. In 2010 and 2011, there were nearly 3 million acre-feet of water that crossed the Wyoming-Nebraska state line at the state line gauge. And that was after all the North Platte reservoirs in Wyoming were full. In other words, full reservoir means that we had met our downstream obligations. This was water lost to Wyoming users. How much water is that? Enough to fill Pathfinder Reservoir 3 times. How many center pivots could you run off that? I got the 2 million acre feet from Matt Hubler at the Wyoming State Engineer's Office, and I started asking if we spend a lot of time and money doing riparian improvement and revitalization, is that going to save enough water to be worthwhile? Here's his answer. You bet. Yes. Even more important than saving water from crossing the state line is saving water, particularly with climate change and the warming climate, saving that water so that we can have a late season stream flow. That the warmer our climate gets, the more critical that late season stream flow is going to be. Photo of the flood in Colorado in September. Now think about this. In 2011, we had record floods from western snowmelt. 2012, we had drought. I don't know about the rest of the state, but southeast Wyoming was the driest on record. 2013, we had spring and summer drought and September floods. And that sequence of extreme weather events fits exactly with predictions made by climate change scientists. Flood damages in 2011 were $8.4 billion with a B dollars. Estimated damage from September Colorado floods, $2 billion with a B. You know the insurance companies have taken major hits. Hurricanes, tornadoes, floods. Those guys are hurting. And I'll bet they're looking to recover some of those losses. If they learn about watershed conditions, I wonder what they would do with that. So we now know how we got to this. The question is, and I hope we have time for question and discussion, how do we get back to this? Brian? Oh. Here we have a hummock specialist. Stand up, Mason. They know who the hummock specialist is. So the question is, one is this, do we have lower organic matter outside? That was part of your question. The other part of the question was whether, if there's a real cause and effect relationship downstream versus upstream of the wetland. Did I get it? Okay. Is the hummocking an effect of grazing? And I think our study just showed that it is an effect of grazing. We have to accept the statements of Manguson, Corning, and Johnson-Carey. That was our test, and we rejected the null hypothesis on that. So grazing does change the microtopography, does increase the surface roughness index. As far as the organic matter, we did test some other areas besides inside, and when you get away from the effect of the mass up above the fence, we found soil organic matter levels down as low as 12%. in hummocked areas such as the badly hummocked area that I showed you. So we have lost organic matter in those sites. Right below the fence, inside was 50%. Right below the fence was, I can't remember, I think 30, 36%. John, do you remember? Yeah. And we suspect that could be influenced by organic matter coming down out of the sponge, the mat, up above. When we got, like I said, when we got away from that, we were getting numbers in 12, 15, 18% organic matter. Oh, I see. The question is the difference in greenness due to the fact that cows are on the land taking off, harvesting the forage? And I guess that could be a possibility. The argument or the suggestion against that would be the over time sequence. Like in 2012, there was hardly any vegetation below the fence. But in some of the other photos, there was vegetation. Like in the first one I showed, 2008, it was green, but the water was just concentrated in the channel. So I think you're right to point that out. I'm sure grazing is removing some of the vegetation, whether it's removing a base to provide a reflective surface that shows up in the photo. I don't think that they would graze at that. I mean, they're not pulling the plants out. So there's still a reflective surface there. How much of an effect, if they've grazed that before we got the photo, how much of an effect would be there, I'm not sure. But I think it is, that's an important question, and we should think about it. Other questions? Yes. The question is, how long does it take the hummocks to develop? And the answer to that is, I don't know. I do know there's a horse pasture in Cheyenne where the water leaks out of the tank down to a depression, and the hummocks are there. So I don't know. Let's see, is Scott still here? Scott, you've mentioned to me a few years ago turning some livestock into a wet area and hummocks formed. Do you want to comment?
Yeah, thank you. Yeah, it can be different. I've actually taken the wet sponge, if you will, the bladder, I call it, the mattress that holds the water, and have actually created hummocks in a grazing season. Seen it happen on private land. There's definitely an impact associated with different types of animals and animal weights, and it can be done fairly effectively. And going back, taking that backwards, I've mechanically tried to modify those, and that can be done following that season of use. But I think continuous year after year after year, you'd start to develop what you're seeing up here on the screen. Yeah, this is my own little personal research world, you know, at home. I've done it with mature cows versus yearlings versus horses, and to me, the weight of that animal and the shape of the hoof has a lot to do with formation.
I think we're going to take one online. We're going to take one online question since we have one.
We finally got an online question. We're going way long on this session, so we've got one very long online question for you. We're going to address that, and then we're going to move on. We can talk about this more after as well. So, Karen Claus with the NRCS in Pinedale asks, in reference to the variability between individual sites, were your sites all the same ecological sites? She has often postulated that riparian sites that are high in carbonates tend to be more susceptible to hummocking and grazing management because of, number one, because of soil chemistry, and two, because they are more preferred by livestock. Can you shed any light on this?
I would have to double check, but I think that they were all in the same ecological site. I can't remember the name of that, but because they're in that one area. John, do you have a...
Most of the ecological sites that Terry had on the screen are in the 10 to 14 High Plains Southeast sub-irrigated sites. They are not saline sub-irrigated sites, they're sub-irrigated sites. There is one area we're still looking at that is in what they call a wetland, 10 to 14 High Plains Southeast, but Terry didn't show any pictures of that today.
Let's thank Terry for his presentation.